Okay, so question number 7 inasema, with the aid of diagrams, describe 3 types of kurtosis. With the aid of diagrams, we are discussing question number 7. Question number 7. With the aid of diagram, describe 3 types of kurtosis. Now, if you look at your notes, you will find that we talked of 3 types of kurtosis. There is something like that. You look at your notes. Now, this one we give it a name. This one, it also has a name. And this one also has a name. So the first one, we called it leptokurtic. Leptokurtic. The second one, we called it mesokurtic. Mesokurtic. And the last one is called pratykurtic. Pratykurtic. So that is what we said, the 3 types of kurtosis. Kurtosis is a measure of pickedness. It's a measure of pickedness. How picked the data is around the mean. So the most picked, the one that is concentrated stream, is called the leptokurtosis. The next one is called ile iko katikati, that is equal to the normal distribution. We call it the mesokurtosis or mesokurtic. Na hii ya mwisho, that is a bit flat, we call it pratykurtic. So that is what the examiner expected the candidates to do, to explain the 3 kinds of kurtosis. Now consider, part B, consider the following hypothesis. Mu is 400, and the alternative is that mu is not 400. For a random sample of 12 observations, the sample mean was 407, and the sample standard deviation was 6. Using a significance level of 0.1, advise whether the null hypothesis should be accepted or rejected. Now, what do you think? Is this population known or unknown? Because you said when you're dealing with these questions, is this population known or unknown? Margaret, what do you think? Is the population known or unknown? Margaret. Sam, is this population known or unknown?
Unknown.
Good. This population is unknown. Is unknown population. Is unknown population because we do not know delta. I told you, if you cannot see this table, the standard deviation of the population, that population is unknown. And then, how many samples are there? Kelvin, how many samples are there? No, 12 is the number of units. We have a single sample. It's one sample. The single sample. It's a case of unknown population, single sample. And you can see even in the wordings, in the summa, for a random sample, Then the other thing is, which parameter are we comparing? Beatrice, which parameter? Is it the mean? Is it the proportion or variance? Beatrice?
Mean.
Mean, good. So it's SIGO mean. SIGO mean. So if it is SIGO mean, then tukasema the first step now is to develop the hypothesis. The hypothesis. The examiner has already done the hypothesis for us, H naught, where we are supposed to say X bar is equal to mean. That is the mean of the sample we are told is 407. So 407 is equal to 400. The examiner ametuambia in the alternate, in the null should be equal to 400. Then in the alternative, HA or H1, X bar is not equal to mu. That is 407 is not equal to 400. That's how we are supposed to put it. 407 is not equal to 400. Haya, kutoka hapo, the second step is to develop what we call the significance level. Is to develop what we call the significance level. Now, significance level, the examiner has already told us that we use 0.01. We use 0.01. Kwa nimeiona wapi? Yeah, actually 0.1. So that is 10%. So we are supposed to say our alpha is 0.1. Our alpha is 0.1. We go to the next step. The next step is called test statistic. Now, test statistic, we normally say T equals to X bar minus mu. You divide by S, which is divided by the root of N minus 1. So our T calculated would then be 407 minus 400. You divide by the standard deviation is 6 and the sample has 12. So it is 6, you divide by the root of 12 minus 1. So compute that as I respond to this call. Just a minute. Tell me the answer. What have you gotten here? Hey, Margaret, give me the answer. Oh, I can see, yes, Margaret has given 3.8694. 3.8694. Good. So if that is the case, let's proceed to the decision rule. The decision rule. Now, this decision rule will be what we call two tails. Two tails, and the degrees of freedom. The degrees of freedom will be 12 minus 1, which is 11. The degrees of freedom will be 12 minus 1, 11. Sasa hii tukasema unachora namna hii. We are on the lower side here, and the upper side here. This one here, this one here, and this one here. Now, I told you if we are on this side, we will say significant. And this significant is the 0.1 out of 2, which is 0.05. Now, if you are inside here, it is insignificant. And this is obviously now 0.9, 90%. If you are here, this is significant, which is 0.1 out of 2, which is 0.05. And this one now will be positive T critical. Positive T critical. And this one now will be negative T critical. Negative T critical. So I want you to go to the tables and read for me that value after umechora. I want the figure. This value you read from the T tables. Niandikie hapo the other minutes. I can see from Margaret 1.36. Umebadilisha 1.79. So which one? 1.7959. That is supported also by Kelvin. Good. So positive 1.7959. So if that is true, then we do the conclusion. We do the conclusion. We do the conclusion. And in the conclusion, what do we say? Do we accept or do we reject? Let me hear from Hilary. Hilary, what do you think? Do we accept, do we reject that?
Reject.
Reject, good. We are going to reject the null hypothesis since T calculated is greater than positive T critical. That is 3.8694 is greater than 1.7959. 1.7959. So what was the examiner asking? Tulikuwa tunaulizwa using the significance, advise whether the null hypothesis should be accepted or rejected. So we already have answered that it should be rejected. So that is answered. Okay, so if we are okay with that, we now proceed to the next question. The next question inasema, a mobile phone manufacturer orders for a special component called PH2 from 4 different suppliers, S1, 2, 3, and 4. 20% of the components are purchased from S1, 10 from S2, 30% from S3, and the remaining from S4. From past experience, the manufacturer knows that 2% of the components from S1 are defective, 4% of the components from S2 are defective, 3% of the components from S1 are defective, and 1% of the components from S4 are defective. All components are placed directly in the store before inspection. A worker selects a component for use and finds it is defective. Now get the probability that the component was supplied by S1 and the probability that it was supplied by S2 or S4. Okay, so that question is on Bayesian theorem. Bayesian, and I told you with Bayesian, you can use either the Bayesian formula or you can use the probability tree. And the probability tree is always the easiest. It's always the easiest. So that probability tree will be like this. We have 4 items or 4 sources. And each one of them is giving us 2, either defective or not. So that means you are going to have 8 tails. So if you are going to have 8 tails, taipanga namna hii hapa. 1, 2, 3, 4, 5, 6, 7, 8. Going to have 8 tails that way. and have it that way. So this is S1, this is S2, this is S3, and this is S4. The probability that it came from S1 is 0.2, is 0.2, is 0.1. S3, we have 0.3. So then this must be 0.4. Those are the probabilities. Then it is either defective or not defective, defective or not defective, defective or not defective. Now we are told from experience, he knows that 2% from S1 are defective. So this is 0.02. So this is 0.98, not defective. Then 4% of L2 are defective, 0.04. So this is 0.96. Then S3, it is 3%. So 0.03, 0.97. Then 1% from S4, 0.01, 0.99. So that is how the tree looks like. When you ask the probability that the defective was from S1, so if you have drawn there, let's get probability of a defective. Probability of defective. Now the probability of defective, we can get a defect defective given S1 multiplied by probability of S1. And maybe this one I can say is probability of defective. All probability of a defect given S2 multiplied by probability of S2. All we can get a defect from S3 multiplied by probability of S3. All probability of a defect given S4 multiplied by probability of S4. Multiplied by the probability of S4. That's what we call the probability of a defect. So this one now becomes, so unafuatilia hizi tu ziko hapa, defect given S1. So the probability of a defective in S1 is this one, 0.02. So it is 0.02 times the probability of S1, 0.2. Plus, hiyo ingine ya S2 ni 0.04 times 0.1. Plus, huyo mwingine ni 0.03 and the probability is 0.3. Plus, huyu mwingine ni 0.01 and the probability is 0.4. So that is the probability of a defect. Solve that and give me the answer. .021. That's 0.021. So the first one, when they ask probability of a defect from S1, probability of a defect given S1. Probability of a defect given S1 will be given as probability of a defect and S1 you divide by probability of a defect. That is how you are giving it. Sasa, this becomes S1 here. It is 0.02 times 0.2. You divide by 0.021. The answer 0.4762. 0.4762. Let's get the probability that the defect came from. Defect given that it was from S2. S2. This is probability of a defect, and S2 you divide by probability of a defect. Probability of a defect. So S2 is 0.04 times 0.1. You divide by 0.021. Oh, the second
Excuse
one.
me, sir.
Yeah?
The first one is 0.1905.
Oh, CO47. Okay.
Yeah, sorry.
Okay. So it is 0.19. 1905. Okay, so now give me the second. Oh, the same. Okay, 0.1905. Haya, sasa probability of B given, hiyo ingine tunaulizwa ni S4. S4, so it's the probability of a defect, and S4 defect and S4 you divide by probability of a defect. Probability of a defect, so this will be 0.4 times 0.01 out of 0.021. Oh, I think the answer will still be the same. What a coincidence. Okay, the answer will still be the same, 0.1905. So when you're told probability of a defect having come from S1 or S2, sorry, S2 or S4, you combine those two, 0.1905 plus 0.1905. So you combine those two, that is the answer. So I think that is good. I want us to log in again because I can see our time is almost in. I want to start afresh in the next question. So we are now going to the next paper. So let's log in again. This problem will be sorted by tomorrow. I don't know why they delayed in sorting out. Okay.